Great work with Lesson 1! You now have a solid understanding on how to calculate string similarity. At the end of the last video exercise, we saw how record linkage attempts to join data sources with fuzzy duplicate values. For example, here are two data frames containing NBA games and their schedules. They've both been scraped from different sites, and we'd want to merge them together and have one data frame containing all unique games. We see that there are duplicate values in both data frames, with different namings marked here in red and non-duplicate values marked here in green. Since there are games happening at the same time, no common unique identifier between the data frames, and the events are differently named, a regular join or merge will not work. This is where record linkage comes in. Record linkage is the act of linking data from different sources regarding the same entity. Generally, we clean two or more data frames, generate pairs of potentially matching records, score these pairs according to string similarity and other similarity metrics, and link them. All of these steps can be achieved with the record linkage package. Let's find how. Here we have two data frames, census A and census B, containing data on individuals throughout the states. We want to merge them while avoiding duplication using record linkage, since they are collected manually and are prone to typos, and there are no consistent IDs between them. We first want to generate pairs between both data frames. Ideally, we want to generate all possible pairs between our data frames. But what if we had big data frames and ended up having to generate millions, if not billions, of pairs? It wouldn't prove scalable and could seriously hamper development time. This is where we apply what we call blocking, which creates pairs based on a matching column, which is in this case the state column, reducing the number of possible pairs. To do this, we first start off by importing record linkage. We then use the recordLinkage.index function to create an indexing object. This essentially is an object we can use to generate pairs from our data frames. To generate pairs blocked on the state column, we use the block method, inputting the state column as input. Once the indexer object has been initialized, we generate our pairs using the .index method, which takes in the two data frames. The resulting object is a pandas multi-index object containing pairs of row indices from both data frames, which is a fancy way to say it is an array containing possible pairs of indices that makes it much easier to subset data frames on. Since we've already generated our pairs, it's time to find potential matches. We first start by creating a comparison object using the recordLinkage.compare function. This is similar to the indexing object we created while generating pairs, but this one is responsible for assigning different comparison procedures for pairs. Let's say there are columns for which we want exact matches between the pairs. To do that, we use the exact method. It takes in the column name in question for each data frame, which is in this case date of birth and state, and the label argument, which lets us set the column name in the resulting data frame. Now, in order to compute string similarities between pairs of rows for columns that have fuzzy values, we use the .string method, which also takes in the column names in question, the similarity cutoff point, and the threshold argument, which takes in a value between 0 and 1, which we here set to 0.85. And finally, to compute the matches, we use the compute function, which takes in the possible pairs and the two data frames in question. Note that you need to always have the same order of data frames when inserting them as arguments when generating pairs, comparing between columns, and computing comparisons. The output is a multi-index data frame where the first index is the row index from the first data frame, or census A, and the second index is a list of all row indices in census B. The columns are the columns being compared, with values being 1 for a match and 0 for not a match. To find potential matches, we just filter for rows where the sum of row values is higher than a certain threshold, which is in this case higher or equal to 2. But we'll dig deeper into these matches and see how to use them to link our census data frames in the next lesson. But for now, let's generate pairs.